Welcome to the series of video on the gasketing process, which comes under your lesson Fabrication. Gasketing is also known as oxyacetylene gasketing or oxygasketing or oxy-fuel gasketing. Why is it so called? Oxyacetylene gasketing involves two gases, namely oxygen and acetylene. This process is used for cutting any mild steel, which means all ferrous metals can be cut by this method. However, non-ferrous metals or their alloys are not to be cut by this method. What is special about this oxyacetylene gasketing? Well, one of the special features of this process of gasketing is that the cut is confined to a narrow strip without affecting the adjoining areas. Let us now observe an animated graphic by which you will come to know the actual principle of oxyacetylene gasketing. There are two processes which are involved in oxyacetylene gasketing. First, a preheated flame formed by a mixture of acetylene and oxygen is directed onto the metal to be cut, raising it to a bright red hot temperature, which is also called the ignition point, which is approximately 900 degrees centigrade. Secondly, a stream of oxygen is directed onto the metal, which oxidizes the metal and cuts it. Remember, both these operations are done simultaneously by using a single torch called as the blowtorch. To enable to get a fine cut, the torch is held firmly and moved in a uniform speed, slowly and steadily. Oxyacetylene gas equipment can be stationary or portable. What you are now seeing is a portable unit. The oxygen cylinders are tall and slender and are colored in black. The acetylene cylinders are colored in maroon and are short and stout. Let us now see the various components of the oxyacetylene gas cutting system. This is an oxygen regulator, which reduces the high pressure of the oxygen in the cylinder to a convenient working pressure. This is the end connected to the oxygen cylinder, which has a right-hand threaded adapter unit, and it has to be turned as shown here. The first pressure gauge, which shows the pressure inside the cylinder. As you can see, this has a circular scale with marking on the outside as well as on the inside. The outer markings of the scale show pressures in bars, and the inner markings show pressures in psi. A pointer moves over the scale and indicates the pressure of oxygen inside the cylinder. Now, this is a safety valve which opens and lets out the gas when the pressure exceeds the safe limit. The second pressure gauge, and this shows the working pressure of the oxygen. This is similar to the first gauge, except that the circular scale has a smaller range. This is the outlet of the regulator through which the oxygen comes out at the set working pressure. It is to this end that the blue colored oxygen hose is connected, and it has a right-hand thread. This is the regulating knob. When you fully turn this knob in the clockwise direction, there will be no flow of oxygen through the outlet, or this is the closed state of the regulator. When you turn it in the anti-clockwise direction, the regulator gradually opens and allows oxygen through the outlet. The pressure of the gas flowing out is indicated by the second pressure gauge. This is the acetylene regulator, and the word acetylene is written on the dials of the pressure gauges as well as on the knob. One point is to be noted here that all the screws and threads of this regulator are left-handed. The fact that the threads are left-handed can be identified by the grooves on the nut. The ranges of the pressure gauges are less than that of oxygen gauge because the cylinder pressure of the acetylene is very much lower compared to that of oxygen. Yet another very important point to note regarding safety is that the acetylene outlet pressure should not exceed 15 psi or 1 bar. The red colored acetylene hose is connected to this end. The operation of the knob is same as explained for oxygen. Now let us come to the other tools. This is a double-ended spanner. One end is used for connecting the regulator to the cylinder and the other end is used for connecting the hose to the regulator. This is the cylinder key, which is used for opening and closing the cylinders. After opening the cylinders, these keys should remain on the cylinder itself, so that we can quickly close the cylinders in case of emergencies. The blowtorch or the cutting torch. You can see two inlets with control valves having knobs, one in maroon color and the other in black. Through the inlet having black knob, oxygen enters the blowpipe, and through the inlet having maroon knob, the mixture of acetylene enters the blowpipe. Here it should be noted that oxygen inlet has a right-hand thread and the acetylene inlet has a left-hand thread. There are two tubes, one big tube which carries a mixture of acetylene and oxygen, and a smaller tube which carries only oxygen. Both these tubes are connected to the nozzle. As you can see, the nozzle has a central orifice surrounded by smaller holes. The nozzle can be changed to suit the thickness of the material being cut in accordance with manufacturer's instruction. The central hole gives out a jet of oxygen. The surrounding holes gives out the oxyacetylene mixture, which burns and forms a flame. This flame preheats the material to be cut. Before fixing the regulator, you have to momentarily open and close the cylinder valve to eject away any dirt or other particles sticking inside the outlet of the cylinder. This process is known as cracking. Notice again the color of the cylinders. The acetylene cylinder has a maroon color and the oxygen cylinders has a black color. Now, let us understand the safety ways for gasketing. The gasketing operator has to fully protect himself with safety wears before he starts a gasketing operation. What he now wears is known as leg sleeves. This protects his feet. Then he wears gloves on both hands to protect his hands. Apron to protect his body has already been put on. He wears goggles to protect his eyes. You can see that the chains are put on the cylinders to prevent them from falling when the trolley is being moved. Various tools for marking and layout of the job are displayed here. This chalk block is rubbed on the surface of the plate to be marked. This is a steel ruler with scales in inches and centimeters. This is a bevel protractor used for marking bevel and inclined lines. Wing compass used for drawing circles, arcs and also for marking equal lengths on a line. This is a center punch used for marking punch marks on a line. This is a tri-square for marking a perpendicular line to another line. Now you are seeing tongs used for gripping hot jobs. This is a set of nozzle cleaning wires. Well, that was a very important lesson, and I hope you have understood the principles, the various equipment, the different tools, the safe procedures that are required for gas cutting. We shall now proceed with exercises. There are 15 exercises according to our text. We have divided the 15 exercises into 15 segments. Each and every segment will contain information on marking, punching and actual gas cutting. We shall now proceed with the first exercise, 3.01.